Let's see one more problem. The problem is 5 point charges each of plus q coulomb are placed on the 5 vertices of a regular hexagon of side L meter. So this is a regular hexagon of side L meter. 5 positive charges are placed at 5 vertices 1, 2, 3, 4, 5. Okay. Find the magnitude of force on charge minus q coulomb placed at the center of the hexagon. So at here we have to find the magnitude of the force on charge minus q which is present at the center. Yeah, to calculate the magnitude first, I would like to draw the direction of the forces. So these two O and the B are negative charges. So there is a force of attraction from O to B, so that is in this direction. That is in this direction. Similarly, from the B to O, it is in this direction. Similarly, from the O to E, since they both are the equal and opposite, so these two are equal and opposite. So OB force O to B equal to O to E. They cancel each other because they are equal and opposite pair. So there is no resultant force between in this direction. Similarly, if we can see same from O to A, the resultant force in this direction of this is the one, and from O to D, the resultant force in this direction. So OA force equal to O to D, they are equal and opposite, so they cancel. So there is no force due to this charge, there is no force due to this charge, there is no force due to this charge, and there is no force due to this charge. And this position the charge is empty, so there is only force due to between this charge and this charge, plus and minus q. Now we will write the Coulomb's law. The Coulomb's law F equal to k times minus q and plus q by, I want the distance between them. So here the hexagon side L, so from here to here the side value goes to L. So here you can substitute F equal to k times minus q plus q times L square. So simply you can write that, in terms of F equal to minus k q square by L square. So that is the final resultant force. Here the negative sign shows about the direction of the force. So the direction of the force is along, if we can represent it here, so the direction of the force is along C2O. C2O is the resultant direction of the force. The negative sign shows about the direction of the force. and the rest of this quantity will give the magnitude of the force. Let's see one more example, NCERT example. The problem is given here. Consider the charges q, q and minus q placed at the vertices of an equilateral triangle as shown in figure. What is the force on each charge? We need to calculate the force on each charge. The diagram made us easy. They made the diagram and gave. So let us analyze the diagram first. So here A, B, C are the three vertices. A and the B and the C are the three vertices. According to given order, they place the charges. At A is the plus Q, at the B at Q, and at C it's the minus Q. And L is the distance between the two charges. We need to calculate force on each charge. Now let's come to at A. The force on Q at A due to B. So these two forces are positive. You can write the direction. So this is the direction of the force at A due to B. Similarly, the force on A due to C. Here A is positive and at C the charge is negative. So they both attract each other. So this is the resultant direction. Now they are representing that as F12. F12 is along in this direction and F13 is along in this direction. F13 is along in this direction. Now we need to calculate the resultant force at A. So the resultant force due to F12 and F13 is F1. So this is the resultant force F1. Similarly, we need to calculate same manner at B and at C because they are asking what is the force on each charge. Now here the time to remember the parallelogram of vectors, the resultant vector magnitude. Let me recall you that suppose if A bar is a vector and B bar is another vector, the resultant of A bar and B bar is R bar. So remember the formula, R bar equal to square root of A square plus B square plus 2AB cos theta. So that gives the magnitude of the vector. So I will use the same formula at here. So by parallelogram law, by parallelogram law, the net force on charge Q at A, that I can represent F1 bar equal to square root of, here the A square, here the A square is, I can take as the force, the net force as F square, since all are having the same magnitude and the direction. Otherwise we can write as F12 equal to K times Q by R square, and F13 is also k times q by r square. So let f12 equal to f13 equal to f. So f square plus f square plus 2f times f to ab cos. Now here we need to substitute the angle. So here theta is the angle between the resultant vector with the vector a. Now the angle between these two vectors, the resultant vector, the angle between that vectors, if you can calculate that, the total resultant vector with respect to that. So that you can subtract from the 180 minus 60. So this is the 60 degrees angle. If you can subtract from this, is the total angle is the 180 degrees. So 180 minus 60 degrees, you will get the resultant as 120 degrees. Now if you can solve this, f1 bar equal to square root of 2f square plus 2f square times cos 180 minus 1 by 2. Now f1 bar equal to f. So that is the resultant force, at charge q. Okay. For further explanation, just it is the NCERT example. All of you go through that example, try to solve it and analyze it by yourself. It's half complete. It's half completed.